Good afternoon, everybody. My name is Keith Robertson, and I would like to present a new language called SABLE. SABLE is a general-purpose programming language whose syntax is derived from Smalltalk, but the object and deployment models are pure .NET. So, why a new language? Well, obviously, I really like Smalltalk as a language that's readable, usable, and highly productive. I love its readability as opposed to the C-based languages. And so I asked myself, well, why was Java successfully marketed as the language of the internet? And could Smalltalk have filled that role? And I decided there were definite reasons that it couldn't, as it was. The way that you deploy applications in Smalltalk is a bit error-prone, and it can lead to images, to files that are too large for internet deployment, especially in the days of the 28.8 modem, which fortunately we've mostly forgotten. But even today, we demand more responsiveness from our internet applications than downloading a 10 megabyte file for an applet would provide. Plus, the Smalltalk environments don't provide needed security for running untrusted code, primarily due to the lack of type information in the bytecodes. I decided to try to adapt the syntax to .NET to get lightweight deployment and a better security model to keep Smalltalk's readability benefits while adding type safety and with no compromises in performance. Also in SABLE, as in Smalltalk, you can create new control flow structures and operators and enhance existing libraries. And with these, you can raise the level of abstraction that's available to you, and so that your code tends to be simpler to read, and you can do more with less. My ultimate goal with SABLE is to create a fluid, flexible, Smalltalk-style environment for development. But when you're ready, your application compiles down to an ordinary assembly with about the same performance characteristics as C#. This would give you a highly productive dynamic developer experience, but without requiring a dynamic runtime. So the heart of SABLE is its Smalltalk-derived syntax for messaging. Now, to be clear, whenever I refer to a message in this talk, I'm referring to the syntax for invoking functionality, not to what actually happens at runtime. But I can't call them method calls because, as we'll see later, a message doesn't necessarily actually call a method. One really nice thing about the syntax is it's very natural in SABLE to do message chaining, where the result of one message is used as input into the next. SABLE also has message cascades, where a sequence of messages are applied to the same receiver. With these, you tend to build up your program structures in a more functional style, which is really quite readable. And plus, keywords and keyword messages tell you what each argument is for within a method call. So, like that. This is really useful because people read a lot faster than we can remember. And plus, there are, tens of thousands, if not hundreds of thousands of methods that are available to you just in the stock .NET installation. It's very unlikely that you've been exposed to all of them, but with keyword messages, you don't have to be in order to know what a piece of code is doing. Strong typing has obvious benefits. I won't read that off. Plus, in SABLE, reference expression types are typed as allowing nil as a value or not. So if you take something that is typed as allowing nil, that's what the question mark is for, and you pass it to something that doesn't accept it, as we see down here, then obviously the compiler will complain. That's pretty much what the earlier talk on IFA was about. Now, with strong typing comes the need for typecasting, which Smalltalk didn't have. SABLE adds typecasting in a way that fits in very well with message chaining. Here we have a stack of nodes. We get the top element, cast it to a block node, get the last argument, and cast it to the proper type so that we can assign one of its properties. For fun, rewrite that in your favorite strongly typed language of choice and see how it compares. Now, strong types are kind of a double-edged sword. They do a lot for you, but they can add a lot of clutter to your code. SABLE mitigates that with bidirectional type inference. Now, most languages now are doing some kind of inference outward from an expression.
Can you explain a little more about what casting actually means? Is that pulling out an aspect? Is that creating an interface?
No, just typecasting, just like in any other language. Yeah, well, the question was, what does typecasting mean?
So I'm actually extrinsically typing the object as opposed to reflectively typing.
Yeah, it's a strongly typed language. There's that was a typecast. It's just that it goes after instead of in front, like you see in other languages. So it kind of gives you a flow. You read that left to right, and I think it's pretty easy to read. So most languages now are doing some kind of inference outward from an expression. Here, this declared variable is getting its type from the assignment. The method overload gets its type from the argument. And here we have a method type parameter being bound based on the argument that's passed to the message. This is an array of string passed to a list of t, and therefore t gets bound to string. We see that now in other languages, but inferring into an expression can also be quite useful. Here we're constructing a label, and we want to assign its font property. So this thing must be a font. Therefore, I can leave the type off of the constructor. Then this declared variable gets its type from its lexically first assignment. And there's other type inference going on here. That happens to be a float 32 because that's what the constructor takes. That's a font style. That's a content alignment. Now that syntax, a pound sign followed by an identifier or message expression, is a symbol. And here we see one of the uses of a symbol in SABLE is to specify an enumeration value. This usage really shines in particular with flags enumerations, as we see at the very bottom there. There's no need to specify the type with each flag, in fact, with any of them, because all of that is inferred. The hallmark of a good language, I think, is when its various features combine in ways that make them more powerful and more expressive, and as opposed to clashing and colliding, as we sometimes see. In SABLE, type inference mixes very well with type casting. So if I take an expression, here typed as object, and I assign it to, in a context where a typecast would be necessary, I don't want the compiler to assume that I have that I want a typecast there, because that could very well be a mistake on my part. But I don't mind telling the compiler that I want a typecast here, but you can figure out what the type is. So in just a very brief thing, few characters, we get a typecast construct. SABLE also has a very simple syntax for casting to and from nillable types, and down at the bottom we see the earlier example corrected. SABLE has structured definitions for the assembly, class, and method, which gives you a good place to hang your documentation for each. In Smalltalk, you have to comment your classes separately from the class definition, and what I often found is that that comment either doesn't exist or quickly falls out of date, and that won't happen in Smalltalk, in SABLE. This example shows a assembly definition for a very simple assembly. You see its use, the way it does use clauses. This example is a class definition for SABLE root node. Inherits from SABLE body node. It's declared as an object as opposed to enumeration or interface, etc. Now that syntax, a message expression inside curly braces with a tilde as the ultimate message receiver, is called a pragma. SABLE uses pragmas to help define assemblies, classes, fields, and methods where most languages would use reserved words, which SABLE doesn't have any reserved words. And it shouldn't surprise you that there are actual method definitions in the system that define what these messages are and where you can use them. Replace the tilde with an @ sign and you get an attribute pragma, pun intended, where messaging syntax is used to define the metadata attributes. Here we see some field declarations along with the class definition, and you tend to group field declarations that have the same kind of properties together, so that reduces the amount of verbiage that you have to look at. The constant is static read-only. Something central to SABLE is the macro, which you define and use just like other methods, but they're always inlined when used. The advantage of that is that you can add them to existing closed libraries and encapsulate common usage patterns. A very simple but illustrative example is in that first example line, getting the last element of a list. There's no need to take method def arguments and assign it to a local variable just so that I can get the count, subtract one, and then get the element at that index. All of that is done for you when the compiler inlines the macro. Macros can also accept block arguments, which let you create new control flow structures. Small talkers will be familiar with that next example. Here we have a dictionary of employees. We want to get the employee with a particular name. If it's not there, then we want to create an employee with that name, add it to the dictionary, and return it. We see some type inference going on there as well. The next example, a list of customers, and we wanted to get just their names. Everything you see here is strongly typed. If that is a collection of customers, if customers is a collection of customers, then C is a customer object, strongly typed. And C name is presumably a string, so the result names is a list of string. Down at the bottom is the method definition that makes that possible. The collect macro, its argument is a block that takes the collection element type as an argument and results in the block parameter type, R, which here is bound to string. Therefore, the result is a list of string. This shows another usage of the symbol is to specify a method to be used as a delegate. Delegates can also be bound to a particular receiver. And then finally there I show what SABLE calls a delegate block. You probably know it as an anonymous delegate, where the compiler will generate the delegate method for you. I have planned to have compiler plugins that would allow you to actually use the delegate block to generate other kinds of objects like expression rather than the delegate. That's not done yet. SABLE has a very easy syntax for creating arrays. Runtime arrays are newly created each time you hit the statement. We also have constant arrays. The array element type, you can either give it explicitly, like you see at the bottom, or it can be inferred from the expected type or from the first element type in the array. Again, the goal here is to reduce the amount of noise. Increase the signal, reduce the noise. The types can be inferred both by the compiler and by the programmer, so let's not specify it. SABLE has the return statement from Smalltalk, introduced with a caret, followed by the expression to be returned. This returns true if the static flag is set. We also got a throws statement for throwing exceptions and a no return statement for calling methods that don't return. Now, you don't use this very often, but when you do, this is much better documentation than a comment that says this method does not return. Plus, the language syntax doesn't let you put any dead code after this. Now, SABLE doesn't have any reserved words, but it does have a handful of predefined identifiers, one of which, an important one, is called myType, which acts kind of like a method type parameter bound to the type of the message receiver. This is really very useful. The clone method in SABLE specifies that the return type is the same as the receiver's type, so you don't need to cast it, as we often see. Also, operators, most operators specify that the argument type and the return type are the same as the receiver's type. And the compiler will, for equality, the compiler can check that the right-hand side is compatible with the left, at least regarding their compile time static types. And these are some very simple examples. There are more complex, interesting examples, but then I'd have to explain them. It would take too long. Now, although SABLE derives a lot from another language, there were still choices to be made, and I found it useful to be guided by some principles. The first there is to establish and use contextual information. Context is something from the theory of knowledge. That could be a whole talk in itself. I can't really go into it in detail, but one example of that is that every definition begins with the name of the thing that's being defined. So all attributes and comments go after that name. So the context of what you're talking about is established before you start talking about it. That's good for readability. Reduce the need for comments by showing programmer intent in code. We see that with a no-return statement, with the empty typecast, and with so-called null tracking. There's no need to put a comment in your method that says, this method will not work if you pass nil as an argument. You get that by the absence of one character in the argument's type. Infer types where possible, group similar things together to avoid repetition, and of course the KISS rule. The SABLE syntax is so simple, you've actually seen probably 75% of it in just this short talk. Now for a shameless plug. I'm here to sell you something, which you can tell because I'm the one with the tie. The concepts, overall concepts are proven, including everything that I've talked about. SABLE also has a really very good code generator that generates type IL, for those of you who care. But there's a lot left to do. Attributes don't actually, aren't interpreted. They don't generate anything yet. Contracts, you can put them in for documentation, but they don't generate anything yet. You can certainly build graphical user interfaces in SABLE, but you have to do it yourself. There's no kind of GUI builder at this point in time. Of course, that's a tools issue, not a language issue. Hopefully the tools will come along. The market would be, well, I hope that anyone who writes for .NET would enjoy using this language. In particular, disgruntled ex-small talkers like myself who wishes that programming languages were a lot prettier than they've turned out to be and thinks that that's important. I also know some projects some companies are looking to migrate projects from Smalltalk to something more modern, as I've heard it put. SABLE might be a natural choice for that because the syntax is so similar. Some things would probably translate over without modification, or little modification. So the website is sable-language.com. FYI, the compiler has been translated into SABLE, and it runs on .NET as a command line compiler. It can compile itself and still run, so that kind of proves that it works. But a command line compiler is not the developer experience that I'm going for, so for that reason and others, I'm not making that version available. The version that you can download now is hosted in Syncom VisualWorks Smalltalk, where you get color syntax highlighting, really good code formatter. Incidentally, the SABLE compiler codebase began its life as a Smalltalk formatter, which then got converted to SABLE. So check it out, and I guess that's it. Any questions? Yep.
So once you compile to .NET, all the usual stuff, changing classes on the fly, all that, you're implementing that as a layer of an interpreter on top?
No, there's no layer. It's a static language. You can think of it as C# with SABLE semantics. The question is, what happens to your dynamic ability to change classes and everything? How do you retain that while after compiling to .NET? And it's not retained. Anybody else?
I guess, what class of problems do you see SABLE being able to grapple with better than existing languages?
Mostly readability. What do I see it grappling with better than existing languages? And I would say readability. One thing that I one thing I like about Smalltalk is the way that it uses contextual information, and I really strove to keep that with SABLE.
Is that reuse or?
No, readability. The ability for a programmer to look at a piece of code and understand it quickly.
So maintainability.
Yeah, that's part of it. I mean, you're going to read a piece of code a lot more than you're going to write a piece of code. I mean, before you can write it, you have to read it at least once. At least you should, right? So I think readability is very important. And the way it reads left to right, and you always have a receiver that kind of tells you what you're looking at. Yes?
What kind of unit testing?
Ask again?
Unit testing? How do you unit test it?
I don't have any specific support for unit testing, but any kind of SABLE has, you should be able to use any .NET library. It's just an ordinary .NET language, so any kind of libraries for unit testing that you would have written in other languages, you could certainly use them in SABLE. Yeah.
You talked about my type. That doesn't always scale very well because you might have a family of related classes, and then you don't want a single my type. You need to refer to everything in the family. Does that work in your system, or is that something you haven't thought about? Is that what the
How does my type work with the family of things? I'm not really sure what you mean by that. I think maybe I wasn't clear then on what my type means. My type is used in method heading definitions, and it can also be used in macro bodies where it gets inlined. But it's just what it represents is the static compile time type of the receiver of the message that invokes that particular method. The question is, what is my type all about, and how does it scale with? So if I take some kind of expression and I give it the clone, and I pass the cloned message, which just means putting the expression and then cloned after it. So what this means is that the type of that expression is exactly the same as the type of the receiver of the cloned method, the static compile time type. Does that make sense?
No.
Okay. Say I have.
You can do this offline if you want.
Okay. Well, say I have a dictionary.
The problem is harder than you made it out.
Maybe. Yeah, I can take that offline. But if I have a dictionary and I want to clone it, usually you have to put a cast in order to use it as a dictionary, right? In SABLE, you don't, because the type of this is the same as the type of this. Anybody else? Anybody want to ask if SABLE's open source?
Is SABLE open source?
Thank you for asking. No. SABLE is not currently open source. I don't feel myself qualified to build a business model around open source software. So hopefully I can find a sponsor. If they want to go that route, I would be willing to open source it. Is that it? No takers. Okay. Thank you.